Who hasn't dreamed of living on the moon? I mean, imagine just bouncing out of your house and looking up at Earth. And pretty soon this could be less of a dream and more of a reality. Researchers are actively working on technology that will sustain us for long periods on the moon, from new sources of oxygen to 3D printed domes. So yeah, about that oxygen thing. The first thing we'll need to figure out is how we're going to breathe, because usually we bring all the oxygen we'll need with us on our space adventures. But if we're planning to stay long-term, we'll need a different approach. Here's one way researchers are thinking we could breathe: using air from the moon itself. It took years of work and billions of dollars for NASA to put the first astronauts on the moon more than 50 years ago. After all that effort and expense, they couldn't stay long. Neil and Buzz spent just a couple of hours on the lunar surface. Later missions extended the stay on the moon to a couple of days. But now, with new technology and priorities, the next generation of astronauts are expecting to spend a heck of a lot longer on their visits. To do so, they're going to need food to eat, water to drink, and air to breathe. That's a lot of material to ferry from Earth. So scientists and engineers are exploring what resources they can leverage to help astronauts live off the lunar land itself. One of the most promising ideas is that in the midst of the vacuum of space, the next era of moonwalkers could breathe the moon itself. Well, after a little processing, that is. Astronauts who land as part of NASA's upcoming Project Artemis will spend at least a week, and perhaps more than a month, living at base camp and exploring the lunar surface. China and Russia are thinking even bigger. They imagine a lunar outpost that, like the International Space Station, is permanently inhabited by the mid-2030s. Making these lunar settlements a reality will require launching all the materials and equipment needed to build and supply them from Earth. To reduce the burden as much as possible, scientists and engineers are exploring in-situ resource utilization, the idea of living off the land as much as possible. It's a new term for an ancient idea: bringing only enough supplies to get where you're going and then produce more once you arrive. Of course, the whole idea becomes a lot trickier when you start exploring space. The lunar soil, which scientists call lunar regolith, is a lot less inviting than farmland on Earth, but it does contain a key ingredient for life: oxygen. In fact, lunar regolith is, on average, more than 40% oxygen. That's a big deal, since it is rather inconvenient to stop breathing while exploring. All that oxygen is locked up in the form of minerals, including silicon dioxide, aluminum oxide, calcium oxide, magnesium oxide, and titanium dioxide. Altogether, those 5 minerals make up 90% of typical lunar regolith. So if you grab a fistful of moon dust, you're going to come up with a fistful of oxygen. Excavate just a cubic meter of lunar surface, and you've got more than half a ton of oxygen. Of course, you can't breathe straight up titanium dioxide, so the real challenge is separating the oxygen atoms from everything else. To solve that problem, chemists have been experimenting with rock mixtures tuned to exactly match samples brought back by the Apollo astronauts. In one promising study published in 2019, researchers were able to extract the oxygen using a surprisingly simple process: electrolysis. It uses electricity to do a chemical reaction, like separating the oxygen from the regolith. But the moon rocks aren't very conductive, so the key was to add a material called an electrolyte to help the electricity flow. In this experiment, they used calcium chloride. Then, the mixture is heated to 950 degrees Celsius, which is hot enough to melt the calcium chloride, but not so hot that it melts the regolith. Once things are at the perfect temperature, the researchers applied an electric current that started the process of breaking the oxygen atoms free. After 15 hours, 75% of the total oxygen had been extracted, about a third of which was in a gaseous form suitable for breathing. Would that be enough? It just might. For all our breathing throughout the day, we actually consume a surprisingly small amount of oxygen. NASA astronauts on board the International Space Station consume an average of just 840 grams of oxygen per day. So if electrolysis could free the oxygen from the lunar regolith, they wouldn't need a lot of material per day to support a couple of astronauts. And that's assuming that none of the carbon dioxide the astronaut breathes out is converted back to oxygen. What's more, the leftovers from the electrolysis electrolysis process wouldn't just be wasted. The metal alloys left behind could be used as a construction material or as part of another chemical reaction. Oxygen extraction seems so promising that both NASA and the European Space Agency, or ESA, are planning missions to the moon to test it out. In October 2021, NASA signed an agreement with the Australian Space Agency to develop a lunar rover for launch as early as 2026. ESA's lander, named Prospect, will pursue another promising idea: extracting oxygen from water trapped in ice near the moon's south pole. It could launch as early as 2025. These techniques, or ones like them, will be key for any permanent habitation on other worlds, whether that's the moon or even Mars. When you're going on a trip, you can try to bring everything you need with you. But when you're going to stay, you've got to learn to live off what's around you. Now, creating oxygen is only one of the ways we can repurpose moon rocks. The people over at an organization called Swampworks, yep, you heard that right, are figuring out how to turn lunar regolith into 3D printing material. So now that we have a way to breathe, here's Caitlin to explain how we're getting all of our stuff up there, or maybe how we're going to create all of our stuff up there.
In 2019, NASA announced they were working to go back to the moon, but this time to stay. And that's really exciting. Except to live on the moon, we'll need to do things we've never done before and overcome challenges we've never faced. And to do that, we'll need some brand new technology. Luckily for us, NASA has a place right here on Earth in the marshes of Florida where they're preparing for that future. And it's called Swampworks. And here, science moves fast. Because even though Swampworks is part of a government organization, they have an extremely collaborative approach. So ideas can be developed, tested, and improved on quickly. Swampworks' main goal is to develop tech that will support astronauts on long missions to the moon and eventually Mars. And since they were established in 2013, they've made a lot of progress. Swampworks follows the ethos of the Skunkworks Innovation Lab at Lockheed Martin, which has been around since the 1940s. The work there gave rise to some of the most effective stealth and recon aircraft like the Blackbird and the Nighthawk, and NASA is hoping to achieve the same kind of innovation and success. At first glance, this place looks like a Disneyland for engineers. It's packed with cool tech, exciting projects, and the best sandbox you've ever seen. Seriously, Swampworks has a massive, climate-controlled test bed of synthetic lunar soil, about 110 metric tons of it. But it's not for playing around. It helps teams quickly design, build, test, and improve prototypes, and it lets them immediately see what works in real-world settings. One project that's benefited from this is RASER, or the Regolith Advanced Surface Systems Operations Robot. NASA, you're so good at acronyms. It's designed to help tackle one of the biggest challenges in space exploration, the fact that shipping stuff is expensive. These days, to send 1 kilogram to the moon's surface, it costs around $1 million. So packing things like machinery and building materials would add up to making long missions prohibitively expensive. One possible solution is not to take these things, but to make them using dust or regolith from the lunar surface. A lot of scientists have thrown around this idea, but Swampworks is trying to make it a reality, and RASER will play a big part in that. Until now, rovers have mainly been scientific samplers, only able to collect small amounts of rock and soil. They haven't been made to do serious digging on extraterrestrial surfaces. But RASER will. This isn't as simple as it sounds, though. You can't just send a backhoe to the moon and call it a day. The lower gravity there means everything has a lower weight, so construction equipment has lower traction. Also, whatever you're digging is more likely to go flying around all over the place. RASER gets around this by using 2 sets of toothed drums as digging buckets. These drums rotate in opposite directions, so they cancel out any horizontal forces the robot generates while digging. They also allow RASER to dig, store, and transport about 90 kilograms of regolith at one time. So far, tests on RASER prototypes are going well. The next steps are to test them in lower gravity to see how they fare digging regolith in ice of different consistencies. So someday, this robot could be carrying huge amounts of regolith across the moon or even Mars, helping us collect the materials we need. Now, even if digging works perfectly, there are other challenges to overcome on the moon, like dealing with the dust itself. Lunar dust is worse than glitter. It's very fine, so it gets everywhere. It's electrostatically charged, too, like a balloon rubbed on a sweater, so it likes to stick to stuff. And since it's made of crushed volcanic rock, it's very abrasive and can be hard on equipment. In fact, dust was responsible for many problems on the Apollo missions, from inaccurate sensor readings to imperfect seals. So Swampworks is developing a dust shield like nothing we've ever seen before. It's called an electrodynamic dust shield, or EDS for short. It uses transparent electrodes to run a weak electric current in a wave across a machine's surface. The wave pushes the dust away, stopping it from sticking, And tests have shown that switching it on an already dusty surface will remove 99% of what's stuck. Swampworks scientists envision EDS being used on visors, windows, solar panels, instruments, and even spacesuits. So it could be a huge help. The prototype was sent to the International Space Station for a year of testing in April 2019. So at the time we're filming this video, we don't yet have final results. But if all goes well, the next step will be to integrate EDS into robots like Razor and other tech that will be exposed to lunar dust. So let's say you've got a digging robot and a way to keep your equipment free from lunar dust. Now you just have to figure out how to build stuff. And Swampworks is investigating that too. They're developing what they call the Zero Launch Mass 3D printhead, which will be able to build entire structures from scratch without any materials shipped from Earth. The printhead takes volcanic material from regolith and combines it with a custom polymer to make a sticky concrete. Then once it's given instructions, it can 3D print materials like similar printers on Earth. So far, Swampworks has used simulated lunar regolith to build beams and domes. So things are looking promising, but there's still plenty of work to do, like refining the concrete's consistency and improving the function of the printhead itself. Still, this tool, along with Razor, EDS, and other Swampworks tech, is helping us leap toward a new relationship with space. It's helping us transition from exploration to habitation, and from research to practical engineering. So in time, the results are sure to be groundbreaking, literally in Razor's case.
If we can 3D print whatever we need, we can end up with a full-blown civilization on the moon, filled with 3D printed structures. But with the development of all that infrastructure comes the question of transportation between those structures. We could hop around from one place to another, but I imagine we'd be riding in style. Here's what some earlier tricked-out moonmobiles looked like. It took nearly a decade of work and billions of dollars for Neil Armstrong and Buzz Aldrin to walk on the surface of the moon. But you know what happened after those first historic steps? They went back inside the lander, only 2.5 hours later. And in that time, neither of them even walked more than 100 meters from the lunar lander. To do more science, future astronauts would need to travel faster, go farther, and carry more. And to do that, they needed to stop being moon walkers and become moon drivers. Fortunately, NASA had just the tool for them, the moon buggy. Okay, technically it was called the Lunar Roving Vehicle, but come on. The moon buggy helped astronauts on Apollos 15, 16, and 17 do more science and bring back more samples than earlier missions. And along the way, we built a really cool car. Engineers had actually been thinking about how to build a lunar rover since the early 1960s, but those first concepts were totally different. Some engineers imagined heavy-duty, fully enclosed vehicles that also gave astronauts a place to sleep and work, which was nothing like the final design. By the time the Saturn V rocket was actually flying, it became clear that there would be almost no weight to spare, so the plans had to be scaled down a bit. In 1969, the final contract was approved by NASA. Then the rover was put together by Boeing and General Motors. It was built of aluminum alloy, weighed just 210 kilograms, about a sixth of a modern-day compact car, and had to fold in half to fit beneath the lunar module. But it was also sturdy and could carry 490 kilograms, more than twice its weight, and enough for 2 astronauts, their tools, and a bunch of moon rocks. It even had space for some nice amenities like seatbelts and armrests and fenders. So it was no Rolls-Royce, but considering that it was a car on the moon, it was pretty impressive. The first Apollo missions had shown that the moon's soft, powdery surface could make for uneven footing. So the moon buggy had not only 4-wheel drive, but 4 engines, one for each wheel. Each produced only about 190 watts of power, or about 1/4 horsepower, but the moon's low gravity meant that that was enough for a top speed of about 13 kilometers per hour. The lunar roving vehicle also carried what might have been the world's first dash cam, a TV camera controllable from Earth. That not only enhanced the PR value of later missions, but allowed scientists at Mission Control to look for interesting features as the astronauts drove around. Still, even that wasn't the most impressive piece of equipment on board. The moon buggy also carried a revolutionary navigation computer. Since the moon doesn't have a magnetic field to move a compass needle, and since surface maps didn't have much detail, the astronauts were in real danger of getting lost. And let's be real, everything on the moon just kind of looks the same. To overcome that, a first-of-its-kind computer combined data about the rover's orientation, taken from an onboard gyroscope, with odometer readings from each wheel. That let it track the vehicle's exact meter-by-meter progress across the surface and plot a direct course back to home base. And just in case that failed, each astronaut also had to learn to read a special lunar sundial to determine their direction. Single-use batteries powered everything, but power was never actually a problem. Instead, the limiting factor was the rule that barred astronauts from driving farther away from the lander than they had air left to walk back, a few kilometers or so. That way, if the buggy broke down, they still had a way home. All told, the lunar roving vehicle seemed like a miracle machine, and all that wizardry doesn't come cheap. On average, each rover would cost about $60 million today. Fortunately, we put them to good use. Apollos 15, 16, and 17 each brought a rover, and all were driven more than 25 kilometers over at least 3 hours. With them, astronauts were able to bring back individual rocks with masses as much as 11.7 kilograms, more than half the total picked up on Apollo 11. Also, since the lunar landers had to touch down a safe distance from things like big craters, the moon buggy opened up those areas for closer study on all 3 missions. On Apollo 16, it enabled John Young and Charlie Duke to drive more than 150 meters higher than their landing site in search of samples of that area's unique geology. And the crew of Apollo 17 used their rover to deploy literal bombs on the surface, just in case you needed another reason to think Apollo astronauts were cool. When exploded, these bombs created tremors picked up by seismic sensors and used those to understand the physics of the moon's crust. The experiment revealed that the top layer of the moon's crust is about 1.4 kilometers thick. It's also a lot more broken up than similar areas on Earth, probably because of the constant impacts from space. Altogether, the moon buggies were quintessential Apollo. They were ultimately designed in only months and did so much with so little, relying on clever engineering and state-of-the-art computers to enable exploration. Without them, we'd probably know a lot less about the moon than we do today, which might make them a little cooler than, say, a Tesla. And hey, what's more American than a car on the moon? It's a good thing moon buggies are outfitted with a kind of GPS system. It's hard enough to drive around Earth without getting lost. And based on all of the incredible innovations that researchers are coming up with, the future on the moon is looking pretty cool. If you want to daydream some more, you can check out this SciShow space video with 2 more ways we could live on the moon. Thanks for watching.